أعزائي طلبة وطالبات الثانوية العامة القسم العلمي لغات رياضيات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج كالكولس. النهاردة إن شاء الله هنستكمل مع بعض موضوع behavior of a function وهنتكلم عن concavity and inflection point. Dear students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today is concavity and inflection point. Definition: let f be a differentiable function on the interval open A and open B. The curve of the function f is convex downwards if f dash is increasing on this interval and is convex upward if f dash is decreasing on this interval. When f dash is positive, then the curve is convex downward. F dash is increasing, that means the second derivative is positive, then the curve is convex downward. When f dash is decreasing, that means f double dash is negative, then the curve is convex upward. Theorem: if the function f of x is a function for which f double dash x smaller than 0 over an interval, then the graph of the function f of x is convex upward over this interval. And if the function f of x is a function for which f double dash x bigger than 0 over an interval, then the graph of the function f of x is convex downwards over this interval. Now, definition of point of inflection. A point of inflection on a curve is a point where the curve changes from convex downwards to convex upwards, or the curve changes from convex upwards to convex downwards. In this graph, we have 3 points of inflection. When the curve changes from convex upwards to convex downwards, then we have a point of inflection. Or the curve changes from convex downwards to convex upwards, then we have a point of inflection. Example: determines the intervals over which the curve of the following function is convex upwards or convex downwards, and the points of inflection, if any, exist. The function f of x equals x power 3 minus 9x power 2 plus 24x minus 4. First, we have the function f of x equal x power 3 minus 9x power 2 plus 24x minus 4. Then f dash x equals derivative of x power 3 is 3x power 2, and the derivative of negative 9x power 2 is negative 18x, and the derivative of 24x is 24. Then f double dash x equals the derivative of 3x power 2 is 6x, the derivative of negative 18x is negative 18, and the derivative of 24 is 0. Now we put f double dash x equal 0. Then 6x minus 18 equals 0, and 6x equals 18 by divided both sides by 6, then x equals 3. Now we have two intervals. The first interval from negative infinity to 3 opened, and the second interval from 3 to infinity open. In open interval negative infinity and 3, f double dash 2 equals 6 multiply 2 minus 18. We substitute in f double dash x. Then f double dash 2 equals negative 6, which is smaller than 0. Then the curve of the function is convex upwards. When f double dash equals negative value, then the curve of the function is convex upwards. In the other interval, open interval 3 and infinity, f double dash 4 equals 6 multiply 4 minus 18 equals 24 minus 18 equals 6, which is bigger than 0, positive value. Then the curve of the function is convex downwards. Now we have two intervals from negative infinity to 3. F double dash x is negative and the curve of the function is convex upwards. And the other interval, 3 open to infinity open, f double dash x equal positive values, then the curve of the function is convex downwards. Now we have point of inflection. At x equal 3, the curve changes from convex upwards to convex downwards. Then we have point of inflection. This point at x equal 3, then f of 3 equals, we substitute in the original function, f of x equals x power 3 minus 9x power 2 plus 24x minus 4. Then f of 3 equals 3 power 3 minus 9 times 3 power 2 plus 24 times 3 minus 4, which equals 14. Then y equals 14. The point 3 and 14 is a point of inflection. Another example, the curve of the function f, where f of x equals x minus 2 between two brackets multiply e to the power x, is convex upwards in the interval a, open interval negative 1 and 2, b, negative interval, open interval negative infinity and 0, c, open interval 0 and infinity, d, open interval 0 and 2. First, we have a function f of x equals x minus 2 multiply e power x. We find the first derivative of this function, f dash x equal. This function is a product of two functions. The first function is x minus 2 between two brackets, and the second function is e to the power x. When we differentiate x minus 2, we have 1 multiply e power x plus the first function x minus 2 times the differentiation of e power x, which is e to the power x. Then f dash x equals e power x plus between two brackets x minus 2 multiply e to the power x. Now we find f double dash x. The derivative of e power x is e power x, and the derivative of the product of the two functions x minus 2 multiply e power x is e power x plus between two brackets x minus 2 multiply e to the power x. Then f double dash x equals e power x plus e power x equals 2 e power x plus between two brackets x minus 2 multiply e to the power x. Now we put f double dash x equal 0. Then 2 e power x plus x minus 2 times e power x equal 0. We can take e power x as a common factor. Then e power x multiply between two brackets 2 plus x minus 2 equal 0. Then x multiply e power x equal 0. We know that e power x is an exponential function. E power x doesn't equal 0. Then x equal 0. Now we have f double dash x equals 0 at x equal 0. The two intervals negative infinity 0 open and 0 and negative infinity open. In the first interval, negative infinity open and 0 open, f double dash negative 1 equals. We choose a number belongs to these elements, say negative 1, and substitute in f double dash x. Then f double dash negative 1 equals 2 multiply e to the power negative 1 plus negative 1 minus 2 multiply e to the power negative 1 equals 2e power negative 1 minus 3e power negative 1, which equals negative e to the power negative 1. Then f double dash negative 1 equals negative value smaller than 0. Then the curve of the function in this interval is convex upwards. The other interval, 0 open and infinity open, f double dash 1. We choose a number, say 1, belongs to the open interval 0 and infinity, and substitute in f double dash x. Then f double dash 1 equals 2e power 1 plus 1 minus 2 between two brackets multiply e to the power 1. Then f double dash 1 equals 2e minus e equals e, which is a positive value bigger than 0. When f double dash bigger than 0, then the curve of the function is convex downwards. Now, in the open interval negative infinity and 0, the curve is convex upwards, and in the open interval 0 and infinity, the curve convex downwards, because f double dash x is negative in the open interval negative infinity and 0, and f double dash x is positive in the open interval 0 and infinity. Now, the example say the curve of the function is convex upwards in the interval, yes, 0 infinity. Then we choose the interval negative infinity and 0 when the curve is convex upward in this interval. Another example, if the function f where f of x equals 2x minus a all power 3 plus 4 has an inflection point at x equal 5, then a equals 2 or equal 4 or equal 5 or equals 10. Now we have a function f of x equals 2x minus a all power 3 plus 4, and the a is a constant, a known value of a constant. The function has inflection point at x equal 5. Then we have f dash x equal the derivative of the bracket 2x minus a all power 3 is 3 multiply the bracket 2x minus a all power 2 multiply the derivative of the function inside the bracket, which is 2. And the derivative of 4 is 0 because 4 is a constant. Then f dash x equal 3 multiply 2 equals 6 times the bracket 2x minus a all power 2. F double dash x equals the derivative of the bracket 2x minus a all power 2 is 2 multiply 6, which equals 12, times the bracket 2x minus a all to the power 1 multiply the derivative of the function inside the bracket. The derivative of the function inside the bracket is equals 2. Then f double dash x equals 12 multiply 2, which is 24, times the bracket 2x minus a. this function or the curve of this function has an inflection point at x equals 5. Then f double dash 5 equals 0. Then 24 multiply 2 between two brackets, 2 multiply 5 minus the constant a equal 0. We substitute by x equal 5 and f double dash equal 0. Then 2 multiply 5 equals 10 minus a equals 0 and a equals 10. We choose the letter D. Then the value of a equals 10 when the function has inflection point at x equals 5. Another example. Sketch the curve of the function f where f of x equals x to the power 3 minus 3x plus 2. The function f of x equals x power 3 minus 3x plus 2. We have a function, a polynomial function. The example asks to sketch the curve of this function in its domain. The domain of this function is R, all real numbers, positive or negative or 0. Then we find f dash x. The derivative of x power 3 is 3x power 2, and the derivative of negative 3x is negative 3. And the 2 is a constant, its derivative equal 0. Now, f double dash x equal the derivative of 3x power 2, which equals 6x, and the derivative of negative 3 equal 0. To sketch the curve of this function, we find first the increasing and decreasing intervals. Then put f dash x equals 0. The first derivative, 3x power 2 minus 3 equals 0, divide by 3. Then x power 2 minus 1 equals 0. This expression is a difference between two squares. Two brackets, the first bracket x minus 1 multiply the second bracket x plus 1 equal 0. Then x equal 1 or x equals negative 1. Then we have three intervals. The first interval from negative infinity to negative 1 open, and the second interval from negative 1 open to 1 open, and the last interval open 1 and open infinity. The number line determines the intervals of increasing and decreasing. We start by the first interval. In the open interval, negative infinity and negative 1, f dash negative 2 equals. We choose x equals negative 2. Any number belongs to this interval and substitute in f dash x. Then f dash negative 2 equals 3 multiply negative 2 power 2 minus 3. 3 times 4 minus 3 equals 9, which is positive value bigger than 0. Then the function is increasing in this interval. The second interval, in open interval negative 1 and 1, f dash 0 equals 3 multiply 0 power 2 minus 3, which equals negative 3, smaller than 0. Then the function is decreasing in this interval. The last interval, 1 and infinity open. We choose number like 2 belongs to this interval and substitute in f dash x. Then f dash 2 equals 3 multiply 2 power 2 minus 3. 3 multiply 2 power 2 equals 12 minus 3 equals 9. 9 is a positive value greater than 0, then the function is increasing in this interval. The number line determines the intervals of increasing and decreasing. We have increasing in the open interval negative infinity and negative 1, and decreasing in the open interval negative 1 and the positive 1, and the function is increasing on the interval 1 open and infinity open. Now we have point of local maximum and the point of local minimum. At x equal negative 1, it's a point of local maximum value. The maximum value is the y value. Then f of negative 1, we substitute in the original function, f of x equal x power 3 minus 3x plus 2. Then f of negative 1 equals negative 1 all power 3 minus 3 times negative 1 plus 2 equals 4. Then the maximum value equals 4. The point negative 1 and 4 is a critical point and is a point of local maximum value. Now we have the point negative 1 and 4 is a critical point because f dash negative 1 equals 0, and this point is a point of local maximum value because the function is increasing on the left of this number negative 1 and decreasing on the right of the value negative 1. And the function have at x equal 1 a point of local minimum value. Then f of 1 equals 1 to the power 3 minus 3 times 1 plus 2, which equals 1 plus 2, 3 minus 3 equals 0. Then the point 1 and 0 is a critical point and is a point of local minimum value. This curve has two critical points. One of them local maximum value, have local maximum value, and the other has local minimum value. Now we discuss the convex of the curve. We put f double dash x equals 0, then 6x equals 0. Divided both sides by 6, then x equals 0. We have two intervals from negative infinity to 0 and from 0 to infinity open. In the open interval, negative infinity and 0, we choose a number like negative 1 and substitute in f double dash x. Then f double dash negative 1 equals 6 multiply negative 1 equal negative 6, which is a negative value smaller than 0. Then the curve of the function is convex upwards in this interval. And in the other interval, open 0 and infinity, we choose number like 1. Then f double dash 1 equals 6 times 1 equals 6, bigger than 0. Then the curve of the function is convex downwards in this interval. Now we have an inflection point. When x equals 0, the curve changes from convex upwards to convex downward. Then f of 0 equal 0 power 3 minus 3 times 0 plus 2 equals 2. f of 0 equals 2, then the point 0 and 2 is a point of inflection. Now we have a table. The value of x, negative 2, negative 1, 0, 1, and 2. The values of y, 0, 4, 2, 0, and 4. The point 0 and 2 is a point of inflection. And the point negative 1 and 4 is a location of local maximum value. The point 1 and 0 is a point of location of local minimum value. And the 2 points, negative 2 and 0, 2 and 4, is a points to help us to sketch the curve of this function. Now, the point negative 1 and 4 is a point of local maximum value. The point 1 and 0 is a point of local minimum value, and the point 0 and 2 is an inflection point, and we sketch the curve of the function like this curve. We have increasing in the interval negative infinity and negative 1 open, and decreasing from negative 1 and 1 open, and the curve is increasing in the open interval 1 and infinity. The curve is convex upwards in the interval negative infinity and 0 open, and the curve is convex downward in the open interval 0 and infinity. بكده أعزائي شفنا إزاي نقدر نحدد intervals of convex upward and convex downward، وعرفنا إزاي نوصل للpoint of inflection عن طريق إيجاد f double dash x للفانكشن، وعن طريق ال f double dash x equal 0 عرفنا البوينت الكيرف ممكن يغير الكونفكس بتاعته